Okay, going to walk through the software side of the boiler control panel, and this is what it looks like in my Home Assistant dashboard. But before I get into this, I'm going to take a step back and walk through just the overview of the architecture in general. And these files are linked in the description for anybody that wants to dig a little deeper. But at a high level, Home Assistant is acting as the PLC. It's the brain. It's all the actual control logic. My Home Assistant network and setup is really rock solid. I think I've had it up and running for, I don't know, maybe 8 years now, and I've never had a problem. I've never had it go down. I've got a Unify network set up, and all that's pretty solid. So for this to go down, um, something pretty big has to happen. But I do have a single source of failure on the Home Assistant. If Home Assistant stops for some reason or my home network goes down, I'm not getting heat in my house, and that's why I have the manual override. Within the panel itself, though, there are these e-bytes, which is a Modbus uh, set of devices, and it's basically digital in, digital out, which really just act as either syncing sourcing or just dry contact relays. And then I have analog in and analog out. The analog in I have is both current and voltage. And the analog out I have is basically 4 to 20 milliamps of current that can control different devices. And then out, the things that are actually doing stuff, I've got the different inputs. So I have different thermostats. I've got pumps that are being read. So I have voltage and current being read from different pumps. I have different temperatures. I have a pressure transducer. I'm reading the current in the whole system. And then I even have a switch for the manual override that's part of the setup. The signal conditioning is basically all the things I need to do to read the temperature probes. And then the outputs are either the pumps themselves, some of the pilot lights on the panel, this boiler, what's called the TT dry contact. It's basically the thing that tells the boiler that heat the boiler to fire. I've got one zone valve, and then I have the mixing valve, and then the panel has a digital output that I can use, and I basically send that a analog signal that tells it to display either the pressure or some of the temperatures. And then, I have another block diagram here, which is just, highlighting the different power sources and power protection. It's, 12 volts AC for the thermostats and the zone valve. Um, and then, 24 volts DC is the control logic for almost everything. And then, where I have line voltage. I have this physical block diagram as well, which is actually showing the layout of the different things in the panel, and I'll walk through that in the next video of the panel itself. And then lastly, as I was going along, I kept getting confused as to what devices I have. So in ChatGPT, I kept a running list of all the different materials. This is my bill of materials for all the different things. So sometimes I would forget, which panel lights did I eventually use, and then I would pull the specs, and I have a whole folder full of specs and manuals of the different devices and so on. But let's get into the Home Assistant side of it itself, and I'll walk through the dashboard, and then I'll show the brains behind it. Everything you're seeing here is pretty standard, either Mushroom or Home Assistant. There's a little bit more of a complex display logic in some of these things, but for the most part, everything I'm doing is exposed as a Home Assistant device, sensor, or entity in one way or another. And a lot of this is self-explanatory. This is the boiler pressure. I have various other statuses up here. I can see what the outside temperature is, which drives some of the logic. I can see the different supply temperature. This is a second zone 2. This is the temperature of the water going to a small radiant zone. Then you can see here the supply and the return temperature coming out of the boiler. I have a error indicator here, and basically when an error occurs, it gives me all kinds of information on the error. this needs to be rewritten because as I've updated the logic, some of the error logic hasn't made sense. But in terms of the electrical, it's actually quite helpful, and just reading the total current that's being pulled to the boiler, the panel, and all the pumps is pretty informative. I can see how much current per pump, and the Takeo pumps tend to pull the current as as published in the specs, pretty close, plus or minus, a few milliamps. And that tells me, if there's one pump running, I should see about 75, 77 amps for most of the zones. And that's factoring in the main loop, which is a bigger pump. So the total boiler loop current is here, and then the total panel power is here. And I'm pulling all sorts of data and storing that in a database right now, because what I want to do at some point is correlate what's happening in the system with the current, and then that'll tell me. Hopefully, I can detect different modulation levels of the boiler, and plus if the boiler's firing or not firing, and if the condensing fan is running. So I'm hoping to be able to do that just by inferring, and that's why I have this pump bit mask, which is basically saying how many pumps are running, which pumps are running, and how long have they been running, and that'll hopefully, with some machine learning and maybe some other advanced analytics, I can figure out at any given time what the state of the boiler is as well. And then, of course, I can turn on and off the 7 zone circulators manually if I need to. These are the zones, and I have 7 zones. And then this is first, circle here is indicating whether or not the thermostat is calling for heat. Zone 5 has a busted thermostat wire, and that's a guest room right now, so I don't really worry about it too much, but it's always showing calling for heat. The kitchen right now, which is the bulk of the downstairs, is calling for heat. And then this next circle here is saying in blue that, we're on the normal, it's relying on what the thermostat is saying. And then this blue circle here is telling me that that zone pump is actually running. If I go over to zone 3 and I do what I call the God mode, and I could turn God mode on for all of the zones or just one at a time, what this effectively allows me to do is, now that zone 3 is overridden, I can turn it on virtually, and then you can see over here that the thermostat is not calling for heat, but purple indicating that that zone is in God mode, and then the last circle is telling me that, I've basically overridden it and the pump is running, and you can see the pump over here is running. So this is just a way for me when somebody in the house is jacking up the heat, or I need to do something, I can override what the thermostat is doing and manually control it here. Zone 2, I always have an override mode because Zone 2 is a small bathroom with a radiant floor heat, and basically what I've done here, and I can always just turn it on. No one's using it these days, so I usually leave it off. But the Zone 2, as you'll see in a minute, will use a mixing valve that is set to about 100 degrees. And as long as that floor is getting 100 degrees supply water, that room is kept nice and warm. The floors are warm to your bare feet in the bathroom, which is nice after a shower. And no matter how warm or cold it gets outside, that room seems to hold a pretty reasonable temperature. What I wanted to do is, I didn't want to keep that running all the time, because then it would keep the boiler firing all the time. So I've written logic so that, as long as, zone 2 is running, that circulator just runs all the time, and regardless of whether or not the boiler's calling for heat. But at some point, if it gets pretty warm and no one else in the house is asking for heat, the boiler supply water might drop below the 100 degree temp. And I think I have it at 120. So when zone 2 is calling for heat and there's no one else calling for heat, and the boiler supply is less than 125, it basically fires up the boiler. And, in the wintertime, that usually never happens, and zone 2 is just constantly running, whether the boiler is firing or not. And it probably saves me a couple of cents of heating gas a year to optimize that. But more importantly, the boiler isn't turning on and off just because this one zone is constantly firing. Zone 6 is a bigger, I think it's a 400 square foot room. It's a pretty big room. It's got a slab floor on grade. It's got copper radiant floor from 1980s. And what I'm doing in here is I have a mixing valve that I can control. And then depending on what the temperature is outside, a PID controller, which basically is sort of a mathematical control way of zeroing in on what should the mixing valve's position be. And by changing the mixing valve position, it then changes the supply water to the zone. And then what I'm saying is, and I created a little logic that says, depending on how cold it is, so right now it's 37 degrees. So according to my algorithm, when it's 37 degrees, I want the supply water to be 107.8. And what happens is when this zone calls for heat, the PID logic will change the mixing valve percentage to where it should be, or where it thinks it should be. And then it monitors the supply temperature, and it gets it as close to 107.8 as it can. So what happens is, as it starts to heat up, the PID logic or control algorithm will move the mixing valve up and down to zero in on the right mixing valve position that gets the supply temperature as close to the supply target as possible. And then I'm just reading the return temperature to see what the delta T is, which can tell us a couple of things. And I have some graphs down here that are showing what's happening. So that's the dashboard, and then I'm going to walk through the files. And then the bulk of the logic is done in what's called PyScript, which I think is a Hacks add-on, or maybe it's an application add-on. And I have various, and these are just Python scripts. And I did this instead of doing automations, just because writing the Python was both easier for me, allowed me to do a lot more faster and easier. It's more powerful than automations in YAML. It's a lot easier and more forgiving in syntax. And then probably most importantly, ChatGPT can generate these things and manage and maintain them for me a lot easier than automations in Home Assistant. So the bulk of my logic is using these Python scripts using PyScript. And, this is the main control loop. I'm not going to walk through all the logic, but basically, where is it? I have different triggers that happen, and some of that is whenever a thermostat calls for heat, it does a bunch of stuff. I have some health monitoring and health checks, which are basically doing some looking out for different error conditions. I've got this meter rotate, which basically displays 3 different sensor values: pressure, supply, and return temperature on a digital display on the panel front, the panel cover. And this is just simply rotating and doing that. And it has to convert it to a certain number of milliamps for that to work. Zone 1 is an old zone. My house is 200 years old, and this is the original zone. And it goes under a crawl space. And every year, for the last couple of years, when it drops below a zero up here in northeast Pennsylvania, that zone bursts. I get a pipe burst. And so what I've done now is I've written a bunch of logic that, depending on what the temperature is outside, it controls, it wakes up and it just runs some hot water through the zone periodically. And as it gets colder, it just runs it more often and for a longer period of time. And it's basically a freeze, a way to make sure that this zone never gets frozen. Zone 2 is that small radiant zone. Again, it's got a bunch of logic that says, if the thermostat is calling for heat and the boiler doesn't have enough hot water, turn on the boiler. But for the most time, it's just going to keep the zone running all the time. Zone 6 has the PID logic, using the outdoor temperature and figuring out all other kinds of things. The thermostat in this room is also a little sensitive, so I've also found that the thermostat is sort of turning on, turning off, turning on, turning off. So I'm going to add some logic in here to smooth that out. So this is just an example of the ability to add some pretty complex logic to zones and different control to really zero in and fine tune what the boiler and the whole heating system is doing. Zone 7 is this one zone. It has a valve that is used to prevent ghost flow. And yes, they should have used a check valve, but whoever added the zone valve, and this simply says when this zone is calling for heat and the pump is running, it just sends 24 volts AC to the TACO valve. I think it's TACO 571, and it turns the valve open. And then when the zone isn't being called for, it shuts it down. So simple as that. So these are how the main logic gets done. A lot of times this will expose its own sensors and entities, and it's a little tricky to get right, the syntax, but once you get a hang of it, and Python, there's nothing you can't do in here. The only other thing I'll show, and again, this isn't meant to be a whole thing on Modbus, but I did, everything. The panel that I'll show in the next video communicates with Home Assistant via Modbus. So Home Assistant, maybe I'll show this. If you go to Devices, Modbus, this is a Modbus integration, and then I have all these Modbus entities that get created by the Modbus configuration file, and this worked really easily. And you just need to create this YAML file. So I have the eBytes, which is this Modbus, and then I have the Seneca, which is reading the thermostats, or the thermocouples, and then that's another Modbus. So I have those two, and then what it does is it reads the different slaves and addresses and registers, and then creates these Home Assistant entities. So let me see if I can walk through an example. So here's analog in 1 raw value, which I think is one of the thermocouples, and then creates this AI1 raw value entity inside of Home Assistant that I can then reference just like anything else. So I put this all in this one Modbus YAML file. And besides that, I really didn't have to do much more to make the hardware and the software talk to each other. So that's the overview. Here's the boiler dashboard. I'm sure I could do a lot more, but for now, this works really well. And I think I'm at the point where I just need to fine tune the error logic. And then, my next step here would be to read all this data coming out of the electrical and try to figure out a way to understand the different modulation levels of the boiler, and also when the boiler's firing versus not, and when the condensation pump is running. And then hopefully I can optimize the usage and see if I can squeeze out another 10 or 20 years of this boiler. So next video, I'll walk through the hardware side of this and the panel, which actually I found more interesting than the software side of this, but till the next time.